at how to do stoichiometry experiments, in particular titrations. We're going to look at the equipment as well as calculations involving molarity. So it's a technique that enables the concentration of a solution to be determined if a second solution that the first one will react with is known. Or if both concentrations are known, you can study the actual stoichiometry of the reaction with the balancing coefficients. And you're going to use specialized equipment, a pipette and a burette. And the pipette allows a single measurement, so you can extract a volume of liquid and transfer it to a flask. So you've got a narrow jet down at the lower end, a bulb so that the tube wouldn't be inordinately long, and you've got a single measurement in the top tubing there which accurately measures whichever volume you want, and in particular we'll probably be using a 25 centimetre cube pipette. And so place your jet, bottom of the pipette, into a beaker. This one's got water with it, and a pipette filler with a rolling knob on the top, and as you push it round, liquid is drawn up into the pipette. Don't fill it, so you just see the bottom of that bulb is filled, and then you're going to do the cleaning of the equipment first, and with the small amount in there, tip it slightly. You don't want the liquid to run back into the pipette filler. Keep that clean, but you do want it to go beyond the mark in the tube going up to the pipette filler, so that you're cleaning all of the glassware. Once you've done that, then repeat with a small amount of your standard solution to rinse the inside out, because if you didn't, any water from the cleaning that would be residual would dilute your standard solution, so it would be less standard than you thought. And so you're going to fill up to the line on the pipette, bottom of the meniscus on that line, and you want obviously to hold it vertically, and you want to be at eye level to make sure that that's where the bottom of your meniscus is. And you'll then transfer the aliquot, the portion of liquid, to the flask that you're going to do the reaction in. Let it pour out. And then it says here, just tilt it and put it on to touch the side of the Elamar flask there. So any trapped liquid will come out. There will still be liquid there, but it is calculated to expel exactly 25 centimetre cubed at a particular temperature, and it's usually 20 degrees Celsius. And probably nearly twice the length of the pipette, you've got a burette, and usually they are 50 centimetre cubed ones, with the 0 reading at the top and 50 at the bottom. And this allows you to measure several different volumes to be expelled. And again, you will rinse that by putting water through. Remember to have a beaker underneath and open the tap to rinse the jet out, and then rinse it out with the solution that you're going to be to put in it. And so on the right hand side you can see your data collection. Leave a gap for the second reading to write in when you've added all of the liquid that you're going to react. So your first reading underneath at 0. Doesn't actually matter if it's exactly 0, but record what it is again at eye level. Add an indicator for an acid-base reaction, phenolphthalein, and if you've got acid in your flask here, it will be colourless. If you had alkali there, it would be that bright, vibrant purple colour. And then you will add amounts from the burette and look for a colour change. Swirl the flask as you do that, and you will add it until hopefully you can get the colour to change with one drop. It helps if you have white paper or a white tile underneath so that you can see the colour much better. It needs to be repeated a couple of times. You're going to need to refill your burette, wash out your Erlenmeyer flask and replace the solution, the 25 centimetre cubed of solution that's in there. Doesn't matter if there's a couple of drops of water, the acid that you put in there will be that number of moles. And here again, you can just pause this to read the summary and the indicator that you're adding and doing the experiment here. So you've got your calculation, and for equimolar reacting, you can use molarity 1 times volume 1 equals molarity 2 times volume 2, and you've got one unknown here. Here's an example. So you've got 0.1 molar solution of the acid HA and 31.12 millilitres of it, and in your Erlenmeyer flask you've got 25 millilitres of an unknown M2 molarity that you're going to do the calculation. And having done the titration, you've got one unknown, which is your M2. So here we have a different reaction here where you haven't got a 1-to-1 reaction. You've got 2 moles of acid to 1 mole of the alkali with a metal with a double positive charge. So if you know the molarity and the volume of the acid, you can work out the number of moles, which equals concentration times volume in litres. It's a 2-to-1 ratio, so you need half the number of moles of your alkali. So divide it by 2, and then the concentration of the alkali is going to be moles over litres. Need an L under there. And you do the calculation, and that's how you do it. You can still use the M1, V1, but here it equals 2 MV, M2, V2. And here's the calculation. So just pause that and look at that carefully. And so remember, you've got to account for the coefficients if they're not molecular 1-to-1 ratio, and that's how you can do it. But if you work out the number of moles of the one that you know about and look at the balancing coefficients, that is a good way every time. And so just pause this to do these calculations and activities, just to demonstrate your knowledge of titrations. Thank you.